Live. Hello, hello, hello. Welcome in, welcome in. All right, we are live. Welcome in, everyone. I want everyone to first meet Steve. Steve is friendly. Kinda. Actually, I'm not entirely sure if Steve is friendly. But this is Steve. Steve is our first customer shopper. What we're going to be doing today, well, we're going to be kicking off something that's probably going to take at least 3 developing days to complete. It's going to take a while. We're going to look at putting together the shopper for our system, the AI shopper, starting with Steve. And there's several ways you can make AI. Some have their benefits, others are like just struggle to deal with. I dabbled with a few different types of systems, and I haven't really decided which one I'm gonna go with yet. Because on one end it's simple and you can do everything in blueprints, but on the other end it kind of keeps it neater to do it with the what's the little behavior tree. And then there's this new thing as of Unreal Engine 5 that has like state trees, which is supposed to combine the best of both worlds, but it doesn't really. I think I want to do everything in blueprints. It's going to be heavy and janky. However, we have the other systems that allow you to make AI. They're kind of experimental, and I don't want to get to the point where I've made everything. I've made the AI, I've made it work, and I've packaged it, or it doesn't package because I packaged it with experimental features. Or I don't want to get to the point where they start working on it and then they completely change how something is done, and then I have to go back in and redo the AI. Doing this in blueprints is probably the better way to go because it's completely simple. Or I can mix and match. Now, because of the data, we really only need to run a bunch of calculations and maths, and then we use a move to function. Moving to is basically all we're needing. So having a behavior tree for that as well. It's kind of like, well, we only really need to do one behavior based on a bunch of calculations, right? Whether we can find the item in the shop, then we move to grab the item, add the item to our inventory. That's not really a serious behavior that you're going to need to do a behavior tree on. Anything you're doing more than like, if you need more than 2 behaviors, then I'd say start using a behavior tree to keep it nice and neat, but it's not really necessary. So far, Steve, the other way to do it is another experimental feature they've added, and this one is called smart objects, which basically you have a smart object, which is this pink post-it note right here, and then based on that object, they go over to the node, and then once they get there, they do whatever you tell them to do. And I thought that is a really cool system that would help, because when you get on the node, the AI kind of like blocks that node until they're done standing there. So no other AI can come over and like walk through his body and stand on the same node as him. That node would be claimed, which is really cool. I thought that was really cool when I was messing with it. It's this yellow dot right here, and it's essentially this smart object. And you set up smart objects, and then you go into the Well, actually, there's a lot to making smart objects. You go to that, and then that was a montage I was working on. But basically, you add the smart object, and then you add the interaction, I think. Yeah, so I have the interaction. This is the post-it note, and then you add the actual smart object to it. And then the AI searches for it. This is my smart object test. Basically, once it finds it, it plays an animation, and then you end the behavior. The problem with this is it's also experimental. So with this, I basically find all the smart objects available. This is where you would, find the particular smart object. Hey, the running bird, welcome in. Happy to have you back. How's your day been going? This is basically where you have the smart object, and then you tell it to go to it. So this is where you would run the logic for like, oh, which object he's looking for, and whether or not another AI is already using that object. And then you would set it to use. The problem with this is, since it's come out, it's an experimental feature, so shipping it is probably going to be a no-go. And since it's come out, it's already changed how it does stuff. So I had to find another rework solution just to get it to work the way it was supposed to work. So it's very finicky. And I don't feel comfortable shipping anything that's experimental. But it's so cool, and I think it would be really cool if they could figure this out, or they could, definitely get it to a point where it is shippable without crashing or anything. Because I think the smart object system is the system I would definitely want to go with. And it's probably the one I'm going to play around with today, and hopefully it doesn't crash, and then I can go ahead and push out a build with it. And then if that doesn't give me any problems, I would use it. But that really just has to do with the movement and finding the item. Before we even get to any of that stuff, we need to program the items that we've got in the first place. So let me close all of this stuff out, because we're not going to be not going to be walking the AI around today. We have to program all of the grocery items and everything into the system. We have to program your money into the system. All of that stuff is what we're going to be doing today. And we're basically going to be giving the AI its characteristics today. And if we get to moving, I can seriously say that moving them around is probably not going to happen until the next section. But this is the start of building up the AI. So I'm going to close all the interactions for now. There were a lot of plugins that we had to use for like this, so smart objects, and it's so bad that this is experimental. So yeah, it's just not going to be good to try and use that experimental system. I am still going to try to use it, and I'm going to be really upset if it doesn't build out or if it crashes or anything. But yeah, we've got our AI. So let's go ahead and build some stuff. So the first thing we have to build out is your information first, and all the information that belongs to the grocery store. And that is going to go in world settings. We don't. I'm looking for the game instance. That kind of stuff is going to go in the game instance. And if you're familiar with another game engine, let's say you're coming here from Unity, your game instance is like your game manager. It is sort of persistent across levels. If you need to switch your levels, all the data is going to stay the same so long as the game is open. So that's kind of where I would put all of the information that's going to have to do with your money. But I don't remember where to find or where to plug in. Pretty sure you plug it in project settings, because it persists over the course of everything. So game instance. Alright, so the game instance we're apparently using is called game instance. Where is it? Or whose is it? But like I said, it's a high-level manager object for an instance of the running game, spawned at the game creation and not destroyed until the game instance is shut down. So basically, all of your global variables are going to go into here, and then you'll transfer them over to a save data file when you need to save the data, and then your game instance comes back up, and it'll pull from the save data and then maintain that information. But we're not working on saving the game today. I'm just looking to find the game instance, because I think one of the systems that we have plugged in already uses the game instance, and I don't want to break anything when we go to make our own. Now typically I'll make my own, but I want to see if they already were using one. I'm just gonna search to see if anybody used the game instance. Nope. I keep accidentally clicking stuff. Only because my mouse died. It's weird. I changed the battery so it has a fresh battery in it, and now it's just died and it won't work or connect to anything. So I'm using a completely different mouse. So my hand has to get used to it today. I'm trying to find the game instance. It is here somewhere. No results in content. If no one's using it, I'm just gonna make a new one. But it's weird that I don't see it. These are material instances. Does no one use the game instance? There's not a game instance asset here. Maybe it's stored different and I just don't remember. No. Yeah, there's a game instance object here. Why couldn't I... let's just call it... I called it absolutely nothing. And it... What? I didn't even click my mouse and it just saved for me. What? Parent class game instance. That was weird. We're gonna call this the... I can't say BS because Bodega Simulator. Nope. So let's call it Bodega. Alright. So, a few, I guess, differences you'll notice is when you open your game instance, you don't see what you usually... Why are they... For some reason, did they change... For some reason, every time I open stuff now, event graph is next to blueprints in the same tab, and they're not like this. I've been having to do that change that all day today, but yesterday it was fine, so that's kind of weird. Anyhow, you'll notice that you don't have your typical function, so we don't have event begin play, because the game instance just opens up when you start your game anyway. There is no event begin play or anything. It's kind of replaced by init, which just like once the game's initialized, all this stuff runs. And then network error, shutdown, and then travel error. So basically everything you're gonna do is gonna require init. I tend to use the game instance to store variables. I don't really use any code unless something important needs to happen. Now when you do your save and load file, I would use the init to pull the information from the file, but I can't even think of any instance where I used the game instance for other stuff. So we're going to create variables. Very first variable is going to be a float, and it's going to be the most important thing in the game. how much money you have. Player currency total. And I'm trying to be accurate with my naming, but that is way too long. So I'm just gonna say P underscore money total, and P is for player. So player money total. I'm doing this on the fly, so thinking about all of the variables that we're gonna need. We're gonna need to know anything that we're gonna need to know throughout the game. Items unlocked, I suppose. And then I'd store the items unlocked by section. Let me think. Player level. I don't know if I'm gonna do a player level or a shop level. So P for player, S for shop. Because you could get experience points to the player, or I could give experience points to the store. Haven't decided how I'm gonna do that yet. Hey gaming legend, what's up? Welcome in, happy to have you here. First time seeing you around, what's going on? Okay, I'm gonna do player level, store level, and I could tie store level to expansion. So like if you're level, or if I buy the expansion, store okay, what expansion you have unlocked, that's just gonna have to be a long variable. Player level, store level, those are gonna be integers because they're gonna be whole numbers, so and in that regard, we're gonna have player XP and then store XP, because you're gonna up however much XP you have is gonna raise you to the next level. Move it. Okay. Level XP. Move that there. Oh, move it there. All right. What other things could we have? So we've got the amount of money you've got. Okay. So expansion unlocked. The way I'm gonna do expansion unlocks is I'm just gonna Alright, let's do food, F for food. Food unlock. Yeah, I'm thinking whether I should keep the store and the storage expansion separate from each other. Otherwise, yeah, if I kept them all in one, it would be based on that. I think free storage would be nice. I'm gonna include free storage with every expansion that you unlock. Food unlock. Now I'm gonna make a couple variables for this. Not variables. I'm gonna make a enum for this. And I'm gonna call this enum uh, food packs, because you'll be unlocking food in different sections. Or I could just do like pack 1, pack 2, or I could do something like dry goods, uh, dry goods 01, and then is that what they call it, dry goods? I don't actually know. And then say what did you call this, like maybe you'll start fruit and veg or something like that, or snacks. All right, so you'll have dry goods, soft drink, or just drinks. All right, so we'll have a drinks pack, and then I'll have multiple drinks pack, but this is just to get the bases going on. So let's save that enum, and then we come back into here, and food packs that you've unlocked are gonna be basically food packs. Okay. And then I guess by default you're gonna unlock you're gonna be given dry goods 1 by default. But after that, every pack you unlocked, and you unlock them in order. That's interesting. Now that I think about it, we're not gonna unlock them in order. We're just gonna store. Because what if you prefer to sell one thing over the other? As long as you can pay for the license, you shouldn't really have to get them in order. So the best way to do that would be a map and a boolean for the second one. And it just tells whether or not you've unlocked that particular pack, so long as you've paid for it. And then I also need, for the food, I need a struct, because we're going to have to create a data table for the food as well. So let's create the not the data table yet. We have to create the struct first, and this is going to be food packs, I guess. And it's basically going to be pack name, and that's going to be food packs. That's going to be pack cost, unlock cost. Okay, so that's going to be how much it costs to unlock this pack. We'll do whole numbers. It should probably be, we're never going to charge like half change. It makes no sense to charge. We'll just charge whole numbers. And then I need to know what food is included. I guess pack food. Pack food's interesting, because pack food kinda needs not necessarily an array. Pack food needs to be, I think it needs to be an array of all the food types that are allowed to go. How would we reference that? All the food types that are what food comes in this pack? That's difficult. I'm trying to think how I would reference it later, how I would use it later. Depends on how I store it right now. What food comes in the pack? We do have we do have a pack. We do have an enum for food. The problem is the enum for food would give me a drop down menu of one item, and I need multiple items. Mm. Uh, let's make the data table really quick. This is the kind of thing that is like, I'll add it when I need it, because right now I may not think of all types of uses that I have for it. Right? Because wouldn't food packs be... Alright, so we'd have a data table for the food packs. Let me see how that shows up. Alright, we're going to go ahead and add a couple. I don't think that's going to show up the way I'm thinking. Oh, wait a second. Yeah, that's not going to show up the way I thought it was. I need individual items, yeah? Yeah, no, wait. That is how I think. Pack food. Yeah, rice, that's exactly what I thought it would do. Alright, so pack food can be those three things and need to unlock the cost of pack food, say it's $100. And then it would be, it wouldn't be dry goods 1, it would be drinks number 1. And unfortunately, I don't have another set of items to add to drink, right? I kind of only made like 3. Put dish soap. Why would you drink dish soap? You wouldn't drink a candle either. This was just for testing. But yeah, that's how I expect to use it, and that's how it's gonna work. Perfect. So now let's go back to the game instance. Whether or not you've unlocked the food packs is that, and then expansion unlock. Now expansion unlock is different from food packs because food packs you can unlock out of order, roughly out of order. Each one will cost a different amount, but if you have the money to buy one before the other, then you're more than welcome to do that. And then expansion unlock, however, that must be done in order. So that's why it's gonna be sitting here like we're gonna have to make a new struct for this, or a new enum for expansion packs. Did I already make it? No. So let's go ahead and do an enum for expansion packs. And expansion packs is going to have a whole lot more data in it, but mainly we're just going to call it pack name. I mean, no, pack 1. I'm thinking of the struct while I'm making the enum. Actually, I want to give them cool names. So like this one will be, that one will be entrepreneur. That one will be just getting started. Oh, actually, I don't think I can do more than one. This one will be business. Maybe. I'm just trying to think of funny names. Let's delete these two. And when I'm writing in the actual details, this will matter a bit more. But yeah, starter, business, entrepreneur, different things like that. Those are going to be the expansion packs that you get. And then we're going to have to make a struct and a data table for them as well. But we're not going to do the actual building out of those because that takes a lot of information. So, yeah, we're not going to build those out. I just need the E expansion packs. Okay. Alright, so far you've got the total amount of money that you as the player has. Your level, the experience points that's going to raise your level, which I would have to build out another data table for just to show like when you can move up to the next level. Same thing for your shop. Now, I have player XP separate from shop level XP because shop level XP deals directly with the expansions that you can unlock for the shop. Okay, I think... Give me another one and call it shop. Status. That's going to be how clean... I wouldn't say clean. That's going to be a marker that determines how nice the place is and how many people would prefer to shop there. That's going to be... and do an integer for that. Next thing we're going to do is... obviously we need to know what day it is. G for game. Alright, so whatever day we're on, whole number, game, time. Actually, no, we don't need a time. There is a time system built into the game itself that I pull and will show you when the game is on, but time never needs to be saved. Every time you close out and come into the game before you kickstart, it's always going to be the same time. So this is kind of information that needs to be saved. Information that isn't going to change. Like information that when the player closes the game and opens it back up, they need to know. Time isn't one of them. So what else does a player need to know? Player. Say, I'll figure some more information out as time goes on. But let's go ahead now over to, so now that we know all of this information, let's go over to the AI. And let's filter in the variables that the AI is going to need to know when they shop. Because the AI is definitely going to need to know like what food you unlock, because that's what they're going to be looking for. Maybe I should do unlock food in order then. If I do it in order, I can just go down the list. But if I do it out of order, the AI is going to have to filter through this to see what they could possibly buy. Either or, doesn't really matter. It's just... Alright, let's go ahead and open the NPC. Alright. Most of the NPC stuff is going to be randomized. And I want it to feel as authentic as possible, so I'm going to try to randomize as much things as possible. And not try to type in any I'm not trying to hard code any numbers with this. So the first thing they need to know is, I guess I could say what items are purchasable. Okay, items. Alright, so all items unlocked. And then we're gonna need an items list. This, let's just call it shopping list. Okay, so the shopping list is going to be based on, it's basically going to be a map. We're going to have to do a map for this as well. And then the second one's an integer. Basically, your shopping list is going to be what items that you want, and then on top of that, how many of each item you want. And I want to randomize both of those. Then I want to do something called max items. That's also going to be randomized. So how many items that you want to get from the store is also going to be randomized. So when you do your shopping list, your max items, when I randomize it in, it can't be over a total random number. So there are people who are going to come into your shop and they only want to buy one thing. So the next item is going to be list or shopping total. And then I need a this is interesting. Okay, we have the items that we want, right? But if those items are not found, we have to kind of, there's no way to do a multidimensional map. Or like if the items aren't found, plus you haven't found all three of the items there, that's some calculations that need to be made. Oh, okay, all right. So we're gonna have to take the shopping list, and then we're going to have to populate it to a new list called shopping found. And what shopping found is going to do, well, I suppose the shopping list could be the shopping found list. No, because shopping list is what I want. And then shopping found is what we were actually found. So what needs to happen? Is the shopping list needs to populate shopping found. I think this might not be necessary. Do I have to do it that? Let me think. Could I not just populate it one at a time? Nah, I'm gonna do it this way. I'm gonna make that a map, and then the second one's gonna be a Boolean, whether or not you found it. So what's gonna happen is, well, couldn't I have just done that with the shopping list? Yes and no. So I'm doing two separate maps because when I randomize the items for the shopping list, it's going to pull it into no, because then I could just make a shopping list and put 3 items onto it. And then for each of those items, they could just populate into the array. Yeah. I'm gonna have to do it that way. Instead of just doing how many each. Because there's nothing needing to be done with this data. So I'm going to change the shopping list to basically to the second one being the Boolean. And there won't be any need for the shopping found one. Because once I populate the shopping list with what they want, what I'm going to do is I'm going to go ahead and reuse that same data just to see whether or not the item was found. Though that could generate issues later down the line if they're looking for 3 and they didn't find 3, so I would have to see how many they did find. Because basically the AI will go to it if they found at least 1 on the shelf, because there'll be at least 1 on the shelf in order for the shelf to even trigger that they have the item. And then from there, what's going to happen is they're going to do the calculations on how many are on the shelf. Because if somebody buys the last one, then they need to at least know how many they were able to find. So I guess in a way I could put that Nah, it makes more sense to populate now both of them make sense. Yikes. I'm gonna keep them up there just so when I come back I know what I was thinking, and then I'm gonna figure out the best way to do it after the math is run while we are making the AI do its calculations. So basically, how many items unlocked should be an array of the items. Actually, no. Yes. But in order to do that, that should be... I kind of want to run this calculation once at the start of each day. So I don't want every single AI to try to run the calculation on what's unlocked and what isn't unlocked. So that kind of information needs to be run in the game manager. So let's go ahead and create a game manager. And this is a day-to-day manager, not necessarily the game instance, which stores all the extra information. So let's go ahead and create a blueprint. Actor. I just created the game manager like I was in Unity. Nobody saw that. Alright. Game manager. Is that my chair squeaking? I'm sorry. The game manager is going to go... the game manager is going to be in the game. And honestly, I might change the game manager to be the... what's the thing? The computer that you have to use to do all of everything, basically. I'm going to make that the game manager. But the game manager is going to have a variable on it. Let's open it. I don't have a... do I have a table or something? Let's grab ourselves a quick table. Okay. Here's our brand new game manager. That's going to be the table that you use to access basically everything that you need to do inside the game. There. So I want the game manager to be the one telling us like what we unlocked and maintaining that updated list of the items that we are allowed to have. So what I'm going to do is I'm going to go ahead and create a variable called items unlocked. And it is actually going to be an array of all the items that you unlocked. So what's going to happen is, by default, okay, by default you can sell rice and candles. It won't be rice and candles by default, but actually I guess I could tie it to the level, but you'll automatically be on level 1. Alright, so by default you'll be able to sell those things, and then what we want to do is we want to have something called update custom event. And I don't want this always firing either, so it's only gonna update when you unlock a certain item. That way it doesn't always need to check, that way, but the list also stays updated. Basically the check on the list is only run every time you update it, and only run once. So every AI just needs to pull the information from the list. They don't actually need to do the checking. So we're gonna call this update item list, or I just could call it stock list. It doesn't matter what I call it, really. All right. So when so every time I unlock a new item or make a sale, which we haven't programmed just yet, I essentially want to, I'm gonna clear. I have this thing about arrays where they get crazy sometimes. So I am going to clear it, and then I'm going to pull from the data table. And this only happens every time you add new items anyway. I'm going to pull from, let's see, get data table row. And the data table is going to be, I think I stored it in food packs. Let me double check. Food packs, unlock cost. Oh, but I haven't actually stored if it's unlocked. So let me get the food pack struct. Unlocked. That's going to be a Boolean. Okay. All right. And let me just set all of them to true. Unlocked. What? Did I leave? Oh, okay. Single. All right. So I can't have dish soap in both of them, or it's gonna try to pull. That is not, I threw the whole thing away. I thought I could just throw away one. Alright, so rice and candle is in the first one, dish soap's in the last one. And then I want them both to be true. Or I'll leave one true and one false. Why does it say rice and rice? Actually, for the sake of the test, delete that. Rice is the first one, dish soap is the second. Make those true, and then I'll make a new row. And then let's call that snacks. Let's call it 2000. Add an element. We're gonna say that that's dish soap and leave that false. And I'm leaving it false just to make sure that the code is working, because we're gonna pull all of this information into a list in just a moment. So on that game manager, we go look up food packs. We do not want data table row. I'm sorry. It's gonna be column. Data. Get data column. Get hold on. There's a way to pull basically all the items that are true or false without having to loop through. That is not what I meant to press. Let me take a sip of water. Give me 2 seconds. 1 moment, please. Okay. Alright, so what I'm trying to do is get... Pretty sure it wasn't row names, it was... It wasn't row names. Get data table column. I'm pretty sure it's column and string. Nah, it wasn't. I don't want a row. I've done this before because when I print dialogue, I print everything that was in that dialogue section. I think it was columns. Get data table row. Get data layer manager. Let's try this. Get data table column as string. All the row for one column. Huh? Export. What? I think this is it. I think it. Let me see. DT. I'm gonna have to pull up my project and see how I did it last time. It was a combination of two, and I think I used data table row. Get data table row names. Was it row? No, because that gives me that. This gives me that. Out row names. And then I had to plug in each row name to see if the column was true. Yep, I'm pretty sure that's how I did it, but I don't remember which two nodes I used. Not me. I know where I did it. I did it here. That's gonna open. I think the column one is confusing me. The row name is not included. Actually, I probably could have just opened Guilt and had it there as well. It's taking forever to open. Give it a moment to open. Like, making AI stuff like this takes a lot of data and stuff to process. But once you've done it for one product, you've done it for all of them. So it's basically getting all the information in, having the AI find the one thing it needs, and then just duplicating that across every single item that you add into it. So it's a lot of initial setup, but less work as things go on. It's loaded out with a bunch of errors. Some widget issues, I guess. Something must have changed in a plugin I was using and it changed all the widgets. This was in dialogue. Chat manager. I remember pulling get data table row first. Nah, what if it's a multiple? Let's run dialogue. What about run like multiple lines? No. Add lines. Was it this? I had to use a for loop. Oh, for loop it is. I had to basically use a for loop. Get data type. I had to get the row names and then loop through the row names, and for each one of them pull the information and determine whether it was the correct section, which is an enum. I would just be determining whether it was the correct Boolean variable. So it was, because I think I tried to use columns at one point and it didn't work. Because I couldn't get all of the information in the column, so I had to loop through. Okay, get data table row names. Let's do that. No. It was a for each loop here, right? For each loop in the array. Did I break? Yeah, no. Alright, so every array element, so every data table row name, I broke out this, and basically I can branch it here because, alright, so for each that is true, I need to take, for everything that is true, I need to take the pack food and add it to items. So this is why I cleared the array, because we're going to have to add all of that information back over again. And had I not cleared the array at the beginning, all of this stuff would duplicate. So if it is true, so if it is unlocked, we have to add it to items unlocked. And then, sheesh. I'm already on a for each loop, but I still have to do another for each loop. Because each set, because each row, or I say each package, comes with multiple items in it, so that too needs to go into its own for each loop. Okay, so you know what? I just noticed that this reroute node is an array reroute, and it matches this. I'm used to reroute noding just being like circles, and I never knew that they differentiated based on, or I never paid attention to them differentiating based on what type of data you were rerouting. I thought it was just simply an extra node to go the distance, you know? That's really interesting. So that it reminds me visually that, yeah, you're rerouting an array. Anyhow, the array element inside that array is going to be what is added to the end of the list. And again, this is only happening when we update item lost. What was I trying to spell? Update list. Update item list. Oh, yeah, okay. Alright, update item list. Alright, so every time we unlock a new item, we're going to clear that whole list, go through the data tables, and add it to it. There is another way to do it. Basically, you can get the items that were unlocked specifically and send them over to update list. However, if things change in your data table, doing it this way, like recollecting all the data, less chance of an error, I would say. And it's neater and it's scalable, and you can use it in multiple places versus it's sort of like making that hard reference to the item. So do it this way to keep it scalable. And now this is that information that AI is going to need to pull. So all of this was really to pull items unlocked, which needs to be a public variable. I would say, let me go back and get the NPC. I would definitely, because that all items unlocked, this should be an array. Okay, so it needs to know what items are unlocked, and all right, so now when this is spawned in, it is going to get a reference. Alright, it's gonna get a reference to that game manager. Let's go ahead. I think I'm gonna need to use it later, so let's promote it to a variable and call it game manager. And then off of that game manager, we need to get items unlocked. Alright, so, and then set this to this. Okay, and the thing about items unlocked is, well, I guess not. I was gonna say the thing about it is you really only unlock items. Yeah, you really only unlock items at the end of the day before you open up the store for the next day and spawn in new characters. So, but actually no, it can happen anytime. I don't know why you would want to do it during the day while you're playing, because there's a lot to focus on, but this wouldn't actually affect it. The only thing is, if the character's already spawned, the second it spawns in, it gets that items unlocked. So if you unlock something during the middle of the day, only new customers will know about it, and the customers already on their way to your store won't know and won't be able to shop or buy anything new. They basically know what they want when they spawn in before they reach your store. Alright, so the AI now knows all the items that it can have. So now we're going to have to generate some sort of shopping list. Let's generate our shopping list. Okay. I want this to be totally random. So the first thing I want to do is generate, okay, custom event, generate shopping data. The first thing I want to do is decide how many items not necessarily how many items. Let's generate what we want first. I'm not gonna do here. All right, let me tell you what I'm thinking. I'm thinking I can either generate the shopping items first, generate how many of each item I have, combine that to get the item total, or I can set a random max item first and then say you're only allowed to get this many items, but that doesn't really calculate for getting more than one of each item. So if I did the more than one first, let's see. It doesn't matter, but it does matter. Because you don't want every shopper to be buying like 5 or 10 items. Oh, I got it. I'm gonna do the max items first. And then I'm gonna do the max items first, and then I just devise a way to make sure that the items that you're shopping for fit within max items. So that's what we're gonna do. All right, the max items you are allowed to get is going to be the length of this. Well, no, because that's max unique items. But what if you want more than one of something? There's a dilemma. How would I solve this? Because what if you want more than one of that item and I've already restricted you to your max items? I could do a max unique items and then a max item. Or I could just generate the items that they want. Just not put a cap on it. I can do I could do max unique items. Pick something within the max unique items, but have a separate total for max of each item that you want. Yep. Okay, so max unique. Because max unique items are going to be determined by what you have, what you're able to be sold. But max individual items, that's going to be something totally different, right? That's going to be a single integer as well. So max single items, I'm going to say we don't want anybody to clean your shelf out. So I'm going to cap it. I'm going to cap max items at 5. 5, yeah. That sounds reasonable. Especially when you think about the games that already exist and how maybe there's some items that only 4 come into a box. So then you don't really want them buying 2 boxes worth of stuff. So I think capping it off at 5 per item is decent. So let's go ahead and do a random number. All right, we're going to be... That's not what I want. Random integer in range. Now the minimum is going to be 0, and then the maximum, again, I'm capping it at 5, and then I'm going to go ahead and set max single item to, I'm actually going to round this and make it a random float. Or no, nah, that's not necessary. Alright, give me a minimum between 0 and... Oh, I don't know if this random range is inclusive or exclusive. Whether or not it includes 0 or includes 5, or excludes 0 or excludes 5, because then I'd have to make it -1. I'll run some tests later to see if this ever generates... No, why would I want it? I wouldn't want it to generate 0. What am I doing? If it's a max single number, you need at least 1 if you're already running the calculations for it. My apologies for that. Alright, so we can get between... We can already get between 1 and 5 when spawning. Trying to decide if I want to keep this as part of generate shopping list or if it's something we should do when we spawn, but let's not worry about it. Alright. So to generate the shopping list, we're gonna get... Wait a second. Wouldn't I want to do this for every item? Yes. For every item, I'd want to generate a number. That way they're not going in and getting 3 of everything. Okay. Alright, let's deal with max unique. Max unique items can only be... I have to set max unique items. Max unique items can only be the length of the array. Yeah, pretty much. You can only get what we have available. But I'm trying to calculate whether or not that matters. I think I'm going about this all wrong. I just thought, while I'm writing these two things, I'm like constantly thinking about different ways to do it. That's the fun with programming on the fly. I just thought of a new system. I didn't mean to set that, which means, because I've already got everything that's unlocked, so why not do a for each loop, go through every single item, and do a random bool as to whether or not he wants the item. If he does want the item, random integer as to how many they want. Simple. Huh. I can't believe I was thinking of doing all of this. We've got all the items, right? So let's figure out what we want and what we don't want based on what's available. Now, I could do like a weighted system and weigh things more heavily to know, but this should probably be in a function. Nah, I mean, it should be in a function, because if it turns out that the very, very low chance that everything runs no, then we are going to have to rerun the function if we chose not to get anything. Because they're already in the shop, they want something. So let's figure out how this is going to go. Okay, so based on all items locked, we go through every single item, and then we get a random bool. But if we get a random bool, and then we get a branch, okay. All right, so we get a random bool, and we get the branch. Now, if the person says, well, basically, if it's true, that means they want the item, then we're gonna have to generate how many of that one item they want. So max single item. Well, we don't actually need max single item. We just generate it right here. It's just going to be a random integer. Is that random int? In range. Random int in range. So the minimum is going to be 1 because obviously they must have at least one of the item, and the max is going to be, again, I'm capping it at 5. So player cannot get more than 5 of the item that they request. And then after that, we're going to go ahead and set the shopping list. Okay, so no, can I make? So we're gonna have to make the map, and then the key for the map, well, the value for the map is going to be this, and then the key for the map is going to be the item that they said they wanted or not. Okay, now we're running into a little bit of a problem here. And this problem is going to be, what if, by some random odd chance, what if all bools return false? So after this loop is completed, I need to check to see if the shopping list is empty. Or, I guess, do I use valid in this way? No. Okay. Okay, if the shopping list is empty, we will generate we have to generate it again. Why is that there? I accidentally connected that to the wrong one. If the shopping list is empty after the loop is completed, we must then generate that shopping list over again. This is a lot simpler now. Pardon. Now that I'm looking at it, it's a lot simpler than what I was thinking earlier. This is very easy to do a shopping list now. Okay, if the shopping list is empty, just rerun the generation until it's not empty, and then once it's not empty, max unique items is no longer necessary. I'm gonna do a shopping mode, and I need to create an enum for NPC mode, and this is going to help me use the behavior tree to tie to the variable to let me know if I'm in a certain mode, switch the AI over to those tasks. Alright, so in AI, let's just do it in AI. Blueprint, enum. So shopping mode. Alright, so this is going to be interesting. So when the AI first spawn, they'll be arriving. They'll be in arriving mode. Once they got into the shop, they will be in generate list mode, I guess. Nah, the list is kind of generated once they spawn in. So this, I'll just make a shopping mode, and then after shopping there'll be a checkout mode, Why can I not type? And then there'll be a departing mode. So those are the basic modes of an AI, of this AI, which is why I said doing this in Blueprint wouldn't be that bad. It saves a lot of trouble and a lot of the bugs that we're having with some of the experimental stuff, and it's not that many things to do. Arriving is them walking to the store, departing is them leaving out the store, and then shopping is going to be them seeking for the items. That's where most of the behaviors are going to be. And then checkout is just a second set of behaviors that depends on you or your cashier or whatever. So that's going to be the basis of the AI. I'm going to save that enum, go back to our NPC, and change it to modes. I'm actually going to change the name of that enum to call it like NPC. Oh no, it's called shopping mode. So what did I just plug in? I just plugged in something called mode. Huh. Alright, shopping mode. Alright. I have to save, compile. So in the beginning, it's always going to be arriving. And then after the shopping list is generated, we're going to have to set the mode to shopping. And that's when we do a lot of our behavior in seeking. So I was messing with the behavior tree for the AI a bit. I didn't really like it. And it did crash a couple times. But I did a few seeking behaviors. So this is the behavior tree for the NPC. I basically did a sequence and then had it like go to the shelf and then use the item on the shelf. Using the item on the shelf wasn't working for me. And I had but that's because I was using the smart objects at the time. When I tried to use it, the smart objects was like crashing. It's experimental. I could not justify shipping a build with that in the state that it's in. So I don't think we're going to be able to use behavior trees. We might just have to build it right into the blueprint of the AI, especially since it's pretty simple. But this was really cool to use. Basically, behavior trees go from the top down. You have a root, and then you have a selector, which determines this. And then you can use kind of like flow control. I think they call them like decorations or some weird nonsense like that. But it's basically flow control. If something happens, then do this. So this is where I would, decorators. I would add a decorator from the blackboard base condition. That condition would have been, and I so badly want to use this, mode, but I have to add it to the blackboard. I don't have the blackboard open. So you'd basically add a new key, and that key would be an enum, and it would be shopping mode. And then if the shopping mode, this is how you would do it. Key type is the enum, shopping mode, entry. I have to wait. Wait a second. Now I'm trying to figure out where. Wait, would I have to do it in the actual behavior tree? Where'd my tree go? I swear I had the tree open. Oh, they're attached to each other. I'm so silly. The button's like right here to go to the blackboard. The tree, and then I would set it, I would come over here and set it right here. So I have it as the, I have Blackboard based condition. On result change, yes. No, on value change. Key query is set shopping mode is equal to, and then the key value would be, no, this is where it's supposed to go, I promise. This is where it's supposed to go, but it keeps bugging out, and it's kind of the reason I can't. Let me save everything. Yeah. Try again. Okay, here's the blackboard. The blackboard has shopping mode set. Did I not put the right enum in? Hold on. Shopping mode, entry class. Oh shoot. I'm sorry, I lost it. I didn't put it in. I swear I thought I did. It was called shopping mode. I think I just renamed it over here. Alright, save that. Now I should be able to come over here, go to my condition, and be able to, there we go, shopping. So now when it went to shopping, I should be seeking and going to the shelf for each item. Alright. I don't like it being so messy because I'm going to need to use a whole bunch more things for this. So in order to kind of get the end result, because the behavior tree is like the container that holds all of your logic, but the actual logic is being done in things called tasks. Will it let me open the task? Yes, it will. So this is one of the tasks. I don't like that I cannot see that next to that. So basically, you'd be overriding your different functions. And event received execute AI basically is like event begin play for tasks. Oh, I didn't show you how to make a new task. I'm sorry. So you basically make a new task up here. And these are some of the tasks that I already created. But if you want to do a base task, you would click task blueprint base, and then you plug in your own logic from there. Or if you're just doing like a movement thing, there's a find random point there as well. The way I connected the task to the new system of smart objects was a little bit different. So let me go back to the task. This first task, the one where we're seeking the shelf, I get the active location of the control pawn, and then you sort of have to plug in the area you want the pawn to seek in, which I think is a little weird, but obviously if you have a very, very large map, you're going to want to do that area. So this is where you would store a variable. I just plugged them in quick and dirty 2000, but this is where you would store the variable of the size of the store that you're running, but that size would be based on an expansion that's unlocked. So that's a detail that you're going to have to go ahead and plug in to there, but I just said search within 2000 by 2000, whatever. And then you have to make a box. So I pulled in, so now we do the smart object request filter. I'm really sure I shouldn't use smart objects. I want to so bad because it was really easy to plug in and it went right to it. But this is experimental, and you don't want to end up making your entire game and then not being able to build it or release it or anything because you used an experimental thing that Unreal Engine hasn't fully pushed out yet. It's a good system. I mean, it has its flaws, but yeah. So I'm using something experimental. I don't really recommend anyone else does. But yeah, smart objects are basically objects in the scene that your AI can search for go to like nodes. It's like a node system that they can go to specific nodes and perform actions on those nodes. But those actions can be interacting with it as well. So say you have a chair, like if you set this up correctly, they can walk to the chair, and if somebody is already sitting in that chair, they won't touch it. But if the chair's empty, then they'll sit down on it, and the next AI that came up to that chair would be like, oh hey, somebody's sitting there, let me move on. So I think that's pretty cool. But the reason I wanted to use smart objects in this case is because I didn't want, and I guess it doesn't really matter to people, I didn't want the AI facing through each other when they all tried to get the same thing off the shelf. Or like you see in other games where they're all trying to walk into the door and they're just walking through each other's bodies and coming into the store at the same time. Now, people are used to it. It's a video game, whatever. People are used to seeing stuff like that happen. But I thought maybe that there was a way to not have that happen, because also when you use the AI, there's like sort of an avoidance thing where they won't bump into each other as well, and they'll continue on their pathing and try to avoid others. So I thought all of that might be cool. But when you have a small supermarket, they're gonna bump into each other, or they're not gonna be able to get to what they need. So I don't actually know if that's a good idea to use it that way anyway. But basically, after you've done all of the logic you wanted to do, you just have these little branch offs and you finish the execution. You have to finish executing every single node you do, which I thought was a little stupid. Not stupid, but why hard code an execution? If it's the end of the branch, it should execute. It should be done with it. But you literally have to go in and tell it every single spot to execute. And if you miss one, you could get a lot of bugs and errors and stuff. So I would be mindful of that. But let's get back to our NPC. So right now the NPC finds the shelf, but I don't really differentiate between shelves. Didn't I do something random? Yeah, I pulled a random one. So now it's time to differentiate. But in order to differentiate between it, we need to work on the shelves now. So we can stock an item on the shelf, but we then need to tell wait, actually the shelf does have a variable already. I'm pretty sure of it. I think we already did this when we were working on the shelves. Yes, that variable is called current items stored. So what we need our AI to do is we need our AI to search for all shelves that have that current item stored, and then we need it to go towards it. So I'm not gonna I still want to use smart objects, but I don't want to use smart objects. I don't want to build this up and then have it broken and then have to do another system at the end. Also can't wait too long for them to find how would I do that? Alright. I'm gonna try the smart object. So basically, to add a smart object to a shelf, you just add it, actually. Wait, was that the right one? Oops. Let me see. No, I don't think it was. I don't think I added the right one. Hold on. No, I did. So where's my yellow circle? Oh, definition asset. There we go. So basically, these yellow circles are like placing nodes everywhere you want the object to be. Now, if I wanted to, wait, at least that's how I thought you were supposed to do it. Rotate. Oh, you just can't see them when you're not touching them, which is weird. You put it kind of right in front where you want it to interact. And I think they'll go to the center of it, but that kind of depends on where, this really depends on the animation that you have your player do. Right now, I don't have an animation on the AI, but I've got that. So, we need to, let me see. Alright, I don't need that open anymore. So the shelf has the smart object on it and its defined asset. So I want to come back to use shelf? No, this one first. Actor claiming the smart object. Actor object reference. This is gonna be tough, but it's gonna be, for now, we're gonna do shelf. That's not how I did it. So it's gonna look for all shelves. No, I can only do one. That can't be right. There has to be a way to filter out all of the shelves because it's out resulting multiple. Array of smart object requests result in result structure. Yeah, list of smart object slot candidates. Yeah, but I only have one shelf here. I need all shelves and all smart slots. Gameplay behavior, should evaluate user tags. Activity, okay. Let's ignore that for now. We only have the one shelf anyhow. And I'm gonna have to figure out that. But my out results, I don't want a random. I want to decide whether or not it's valid index. I want I want to get the parent. What I would have to do is get a copy, then I would have to, that's a still output smart object request result structure, so it doesn't give me, does that give me the get data registry item? I feel like it's trying to give me a bunch of circles and I don't have a way to get the parent object that the circle is attached to. Because this is giving me, yeah, this gives me all the circles. So if I plug this in right here and saved it, save all. If I went to play this, he ain't moving. He's not moving. I don't know why he's not moving. He moved in the beginning. Why isn't he moving? I haven't changed any. Oh, he's not moving. Because we didn't generate the shopping list or anything yet, and I put that stipulation on him. He should. Let me. No, shouldn't. This should generate the shopping list automatically. And the game manager is in, because that's the table. All items unlocked are stored. But chances are, since these aren't spawned in later, it's possible that he came first. So I'm gonna delay it 3 seconds before I let him do his stuff. Because I didn't change anything with the movement, so he should have been moving regardless. Nah, still not moving. He was moving and coming down here. I didn't stop him from doing that. Oh, I keep forgetting he has to be in the right mode. Generate shopping list is never triggered. Alright. Now we go ahead and generate the shopping list. And then he should generate a shopping list and move. We can also test to make sure that works at the same time. Nah, he's still not moving. He must not have wanted any of my products. And I'm not getting an error either, so. Let me just change game mode. Not game mode. No, because I have a reference to the game manager. Alright, I'm just gonna change this to shopping by default. So I can test that part. Yeah, he's still not moving. So it has to be the behavior tree. This is set. Equal shopping. Oh well, now it's on result change. Because now the result isn't changing, the result is just is. Alright. I have absolutely no idea. Blackboard shopping mode is equal to shopping. And I linked shopping mode on the blackboard. I linked shopping mode to the enum e-shopping mode. What, enum name? No. This works. This is linked up, and then I go to the behavior tree and I say on result we're not aborting is equal to shopping mode. So if shopping mode is equal to shopping, that should work. I'm doing on value change, so what I'm gonna do is print some statements because maybe this isn't firing. Okay. Alright, I'm gonna compile that. I put some print statements in. Nothing. I have a delay. Trying again, don't want it. Generate a shopping list. I need to... That went by way too fast. It said trying again though, so it should have regenerated the shopping list. It shouldn't have stopped. Okay. Okay, so it said generate a shopping list, don't want it, don't want it, generate a shopping list, don't want it, trying again? Why would it go to trying again the second time and not the first? I think I have those two mixed up. If it's empty, yeah, it shouldn't go to trying again here. These are mixed up. If the list is empty, we should try again and regenerate shopping list, and then if it's not empty, the mode should go here. But yeah, so if it's not empty, it should. But either way, it should have still changed it to shopping, even when it was messed up. But let's take a look. Okay. Don't want it, generating shopping list, don't want it. So he found something he want, because don't want it didn't print twice. But the character's not moving anymore. Now, before I added this stupid condition in, he was moving. So I'm gonna have to delete the blackboard condition. He was moving just fine. Yeah, he's moving just fine. What? Why would it read my condition incorrectly? Alright, let's see where he goes, by the way. I don't know which one he's gonna go to. That is so dumb. It was never reading the blackboard condition. And I said it was set up. Which one he's going? Oh, he's going to this one. Now he's going to that one. Now he's going to that one. The way I placed him into the shelves is weird, but why exactly did he go to all three? Oh, he's just pacing. I must have it so he paces between all of them. Okay, so he came to the right position there, but when he was coming down the stairs, he kind of phased through the shelves at an awkward angle. I wonder why that is. Because the point's here, but he came... What? Just go to the one on the other side of the shelf, please. I need to figure out why the blackboard wasn't reading my condition, because it was set up exactly how it should be set up. He's going to the other side now. And he's not turning and facing that way. It's weird. So when he came downstairs, he did it like crooked, but now he's doing everything the right way. He doesn't have a walking animation, so he glides. Okay, that's enough watching him walk back and forth. Yeah, I don't... I have absolutely no idea why that blackboard thing didn't work. It should have worked. Let's look at this. This isn't the only behavior... Well, no, I deleted the other one. Like, maybe I had it on the... Did I have it in the right spot? I did. Add a decorator from the blackboard. Okay. I want the blackboard key to be shopping mode. I want to change the shopping mode to shopping. Unless the shopping mode isn't changing on the character, I see no reason this didn't trigger. Blackboard based condition. Key value shopping is equal to shopping mode. Well, shopping mode is equal to shopping. He should move when I press play. That's a basic statement. There's no reason he found the second thing that he wanted. He's not moving. It's refusing to move. I have no idea. It worked earlier when I set it up. I have no idea why it's refusing to move now. Blackboard shopping mode is equal to shopping. Do I have to link it any further? No, because it's kind of bound. It's bound to shopping mode. Right? Maybe not. Maybe it's not bound to the shopping mode on the character, but it's bound to the enum shopping mode. No, but this is this blackboard is on the behavior tree is on the character, so it should be bound to the characters. No. Alright. When I made this claim handle, I used that in data, so I'm missing something. I'm missing something that it's not firing. Let's print. There's another step that I have to do, and I just don't know what it is. Alright, yeah, it's shopping. It's set to shopping. He won't move. So I need to somehow bind it to the shopping on the character changing, even though he's using the behavior mode. Let's see. How do I do that? Also, this should be instance editable, but and expose on spawn. Because when I spawn them out, or it doesn't necessarily, because its default value is going to be arriving regardless. There has to be something I'm missing in binding it to it. It's not bound to the NPC. There's a way. Entry description. Instant synced. What's that mean? Oh no. It shouldn't be synced. All players aren't going to be shopping at the same time. How do I get this key to be the player's key? Entry category, none. Entry name is the same name for the player. Entry description. Enum, yeah. Enum type. Enum name. Enum is enum valid. So maybe I do it in the behavior tree, but no, the behavior tree only gives me options for this. It doesn't really give me options to determine. It doesn't really give me options to link it to the actual player, so I have no idea. On result change, but how do I change that result? How do I bind it to... I don't even see a way to associate it to the character at all, which is why I thought it happened automatically with the bonding, with the change of the NPC that has the behavior tree on it, but I guess not. Key query is equal to decorator task service. Let me see if there's any kind of Blackboard references inside the NPC. Maybe I have to reference the Blackboard from here. See, the other one I used it directly in the task, so I never had to link it to the object. Oh. Can I do target self? No. I'd have to type the key name in. I don't like that. I did have to type the key name in when I was I don't like hard coding stuff in like that. Get Blackboard from self, I guess? Self wouldn't have the Blackboard. The behavior tree would have it. I don't know. Let's make literal. I don't think I like this. Let's test this one out. It didn't throw an error. Yeah, that's how you do it. I don't like that. Having to hard code the name in that way, what if you change the name? That's gotta be bad for it. And you have to change it in 100 places. That's gotta be terrible, but he's enjoying himself. I can't believe that's how you have to do it. And that's how I did it for the thing and the task, and I never made that connection that that's how you had to do it. That is... Ugh. I can't do it that way. There's absolutely no way. What if I change the name of one thing? It breaks everything? I don't know. I mean, it works. But how much more information am I? And why is he sideways? I thought with the smart object, he rotated to the way he was supposed to rotate when using... Or maybe not. Maybe that's something I'd have to plug in. Okay, cool. Cool. I mean, not cool. I don't hard code any, especially string text. I don't do any kind of string text hard coding like that. You sure this can't be an enum? Like, what? Why? Because that's it's just opening the floor for so many errors to happen. That's so dangerous. And then the second you change one value, you have to find everywhere in your code that you wrote this single value here, and you got to find every place and change it. That's bad. That's... Oh, and then look at that. I just accidentally changed it. That's... I don't like that. But I'm gonna change it But let's focus more on the system behind shopping and everything, and collecting money and stuff from the shopper. How they move from place to place isn't as important today as getting those foundations plugged in. So now that we are in shopping mode, we now have to, well, I guess it is important because now we have to look for the items. Well, no, we can do a few different things. So I want to do willing to pay, and I'm gonna make this I'm gonna make it a float. I think I want to make it a percentage. Do I want to make it a percentage of something? Or should willing to pay be random? If I want it to be random, I could do, if I want everything to be truly random, like I said, the number that they're willing to pay could vary per item. That's one thing I didn't include in the items. Now that I'm thinking about willing to pay, I didn't include the cost of items. Item size. That should go here. Box that fit in. Okay. We're definitely gonna have to find a new NPC system because having to find items that way absolutely sucks. I don't want to jump around though, so let me correct the one thing I was gonna do and then we'll get back to it. It's not the data table, but the struct, I think. Yeah, so I have the what item, the size of the item, the storage type it can go in, the box type, the unit price, okay, the market price, and then there was also something I wanted to calculate sales for items, and then I wanted to calculate like hot items where more people were guaranteed to buy it. But if it's a hot item, that would give it a higher threshold of predictability. Is that playing the same song over again? Let's see. So the next thing we want to do. What? That is the same song. I know I wasn't going crazy. It's just repeating the same song over and over again. Alright. Next song. Actually, let me take something to drink. Alright. I didn't like how he was coming at this sideways. Shouldn't he be facing the item? And this one too. I wasn't sure how they should face it, but that's fine. Alright, let's do some more background stuff for the NPC. Some of the NPC's calculations. So now that they've generated the shopping list, And we know that definitely works. Oh, I took that one more print statement out. Alright, so now we have to find the items, which I'm not entirely sure. You know what? There is a... Can I use that here? There is an AI move to node, right? Where I wouldn't even have to use that system since this is so simple. That system, as nice as it seems with the nodes and everything, then I'd have AI moving in between each other. As nice as it seems with the nodes, it's experimental. So the other way to do it would be to entirely use blueprints. And at the end of the day, as long as it works, it doesn't really matter. The player isn't going to know that you use blueprints for the animation and the targeting. They're not going to know. It's going to take a little bit more code inside each of the NPCs. And if you put out too many at once, which I hope you wouldn't do, if you put out too many at once, it could get a little bit more laggy. But at the end of the day, it's going to save you a lot of time and a lot of frustration dealing with the experimental things. And even Epic Games themselves says, like, please don't ship products with experimental features. So let's go ahead and use AI Move 2, which is going to be directly in the blueprint. So now that we're in shopping mode, we're going to have to do seek custom event. And we're going to call this custom event seek groceries or seek items. So the first thing we have to do is we have to pull that item off of the shopping list. So right now we have a shopping list of the item, pardon me, and how many of that item you want to buy based on what the store is able to sell. Now the store may or may not have it. So one way you could do this is you could scan all shelves. And you know what? I can put nodes. I can put nodes on the shelves. And if those nodes are occupied, I can make it so the players don't walk into each other. I can do all of that in blueprints. You don't really need the smart system, even though it's a really cool, neat, bells and whistles and all. It can easily be done in code. And the code will be, all yours, whatever. So let's go ahead and seek items. What we're going to have to do is we're going to have to get data registry. Oh no. I don't remember. What? How do I get off the shopping list again? Oh no. I don't want anything experimental. Add clear contained find is empty. Not empty keys. Okay. I need to get the keys first. No, I want the other stuff, not the keys. The keys are the integers. How many of what? I need to know what first. Values, values. It's a value key pair. No, they're both green. So it was the keys I needed. Sorry. We're gonna do a for each loop because it's gonna encompass everything that has to do with all the shopping, but it's going to be a very big for each loop because it's gonna include. Should I do it that way? It's gonna include walking around trying to find every single item. Okay, yeah, it's gonna be a huge for each loop. That's okay. Break? No. No breaks necessary. Well, actually, maybe one break necessary because I've run out of water. So, give me 2 minutes. We'll come back to this and we'll kick this off. Back in there. Okay, so the next thing we're gonna do is pick up where we left off. So there's gonna be a very long for loop, and the for loop is gonna pertain to each individual AI as they shop and run through their shopping list. So I know I just got an idea. Remember I had that max item thing? Um, I could generate a random max item number and say that this person wants to get this many items, and then run through the generate shopping list until that item is satisfied. Because right now I have all the items here, and then I have how many of that item they want to get between 1 and 5. So there's a way, if I said, well, I'm looking for 6 items in total, there's a way to, I would do a for each loop with a break. And there's, that's good and that's bad. If I did it that way, the for each loop with a break, it would be bad because if the number's satisfied before they got to the end, you'd see a number of customers only buying the old items and none of them seeking out the newer items. The other way to do that would be to randomize the list of items, so all items unlocked. Randomize that way it would be completely random as to whether they bought the new items or the old items. Random array item from stream. We couldn't do random array, so you can't randomize an array. And the for each loop loops through each and every one of them. How would we do that? Because the flaw with this is they could end up getting too many items, or the flaw with this is like the beginning items will always be more sought after and the later items won't be. So I have to think of a way to make all of the items valued in them. I could also, I mean, I could do like, this person must have this item, but that's kind of separate. And then I could roll probability. Nah, because that still isn't going to allow us to pull from all random items. Let me brainstorm that for a little bit, and then I'll get back to you on it, because there's definitely a way. The same with like the hot items. I wanted to do a hot item where people would be more sought after. And then the probability of them rolling. I kind of want to do this. I don't really want to do min and max random. I kind of want to do like percentage probability, which is a bit higher math, because now we have this hot item here and I want them to roll a percentage or a probability that and then it would still be a random integer in range, but it would be weighted. It would be weighted higher, and then the weights of each of the items would be randomized, and that is a way to ensure that that's a way to ensure that any item is sought after as not equally but as randomly as possible, instead of going through a list like this. Because going through a list like this chances are the first 10 items will always be. Chances are every shopper will have at least one or two of the first 10 items that you sell. And that shouldn't always be the case. It should be like, there should be a weighted probability, and that weighted probability on whether or not they want certain items should be generated with each character. So what I can do is I can run through the list. See, I'm supposed to be doing the second thing, and I'm already generating freaking rewriting algorithms on the fly. But here's how I would do it. I would get this. I would go ahead and run my for each loop. But this time, I would do list weights. That's going to be a float. Alright, so we're not at generating the list yet right now. We're going to go back and redo that, and we're going to calculate. Now, this might not feel like it matters to the player, but something like this is definitely going to matter, because you'll have a player unlock new items, and then the more items that are new that the player unlocks, you'll have a longer list to go through. And say the player only wants 10 items, the probability of the longer that list gets, the probability of the first 10 items being eaten up by the first 10 items that you sell, those earlier items, and the chances that the lower items get left behind or don't get picked up. So I could do a weighted system, and I could go in and randomly calculate the weights here. Or I could do if I don't want to randomly calculate the weights, I could do a personality where it'd be like, this person has this personality, so they're looking for more cleaning supplies. Or I actually just want to randomize all the weights so it can feel more random to the player. Therefore, I don't have any control over what's picked. The player doesn't have any control over what's picked. It's a true random. Alright, so we're going to go through... actually, I need to clear this. Okay. Shouldn't it be clear when they spawn in? Yeah. Oh, well. Wasn't thinking about that, but clearing is just a habit for me before I add anything to any kind of list. So if I'm going to calculate the weights, I'm going to give it a random number. Just, I can do between 1 and 10 or 1 and 100. And that would be like, the more likely they are to say yes to the item, the more likely they are to say no to an item. I can weigh them. I'll weigh them from 1 to 10. Nah, I'll weigh them from 1 to 100. Well, from 0 to 100, because there is a chance that they just don't want that item at all. Alright, so for pretty much for each element, we're going to give everything a weight. Between 1 and 100. Then we're going to calculate that weight based on whether or not they want the item. It's more like how strongly do they want the item. It's not just a yes or no. So now I feel like I should run more than a multi-dimensional map. If the item weighs about 50 and below, chances are they don't. Like if it, because there's other factors that I want to include in this that'll be added later in the game. So if it's weighted below 50, they may or may not get it. If it's weighted below 20, they don't want it at all. Or the likelihood of them getting that item is like very, very slim. And then, but if it's weighed higher, what I want to include is I want to include the willing to pay price. So if it's weighed higher and they really desire that item, if it's weighed like between 50 and 60, they'll get it, but they'll factor in that willing to pay price. But if it's like above 80, they'll completely ignore that willing to pay price and just pay for the item. So it needs to be, there's like shifts, there's like levels to it. And then what I also need to factor in, this is why you can't really just, I don't really want to do like a true false, whether they get it or don't get it. That was good to set up and see how the system worked. But at the end of it, you really want to go in and do like some hardcore math. So it needs to factor in a hot item, because if the item is hot, that item is going to add to the score. So let's go ahead and get the hot item. No, not set it. Alright, so if it equals... Okay, so if it equals the hot item, whatever your score ended up being, it's going to increase it. Hot item gets set every day. So at the beginning of the day, I'm not going to do this. At the beginning of the day, I need to set the hot item. The game manager doesn't have a hot item yet. Is this the manager or the instance manager? Okay, so there's going to be a hot item that everybody just has to have. And then I need to do... See, I want to include some kind of sale, but I can't really force the player to have a sale and say like, hey, sell these for a little bit lower, and I can't do that. They have to be willing to do a sale on their own. the best thing I can do is like say hot item or something. Wait, did I save it? So we have a hot item. I'll figure out the sale thing a bit later. But hot item needs to factor in. So if, let's pull it here. Alright, so I'm gonna move this down some. Alright, so if it's the hot item, I want to add a little bit more weight to it. Do I want to add a consistent weight or a randomized weight? Either way, it's getting added weight. I'm going to do a randomized weight because what if they don't care about it? Yeah, it's the hot item, but what if they don't care about the hot item? No, I can do random float. Wait, no, because it doesn't know. Returns a random float between 1 and 0. No. I was gonna do between 1 and 0, but I chose not to. Just to give stuff more flexibility and probability, because there's going to be a lot of items. I actually was going to do 1 in 10 originally, but random float in range of or I could just multiply it by a tiny percentage. Give it a little extra boost. Nah. I don't want it to give it any more than 20 points, though. 20 is the max you're allowed to give it. So if it's the hot item, we're gonna go ahead and add 20 points to whatever your total would have been. Nah, I think 20 is huge, but I haven't really devised the entire system. Kinda thinking of this on the fly. Because 20 could push it over the edge of like, I'm definitely getting this. I'm gonna do 10. Because 10 could still be in that range of like, yeah, it's hot, but I don't really care about it. If your numbers are really, really low, and it ends up in the hot item, yeah, comes in, you could still like not care about it. Okay, so let me make this a little bit more neat. Okay, smooth that over. So if it is the hot item, then we're gonna add a little tiny boost. And maybe that boost is enough to push you over the edge of like, I'll buy it, or over the edge of I'll pay extra for it, or something like that. Or maybe it's not. No, that's too high. That's too close to everything else. Move that down a lot. There we go. Alright, and if it's not the hot item, no, whoa. Alright, so if it is the hot item, let's go ahead and alright, so if it's the hot item, let's go ahead and do that. And if it's a not hot, I mean if it's just a normal item. And I'm trying to think about whether or not I do more than one hot item for the day. But nah, that's not necessary. Okay. So we have our weight with a little hot item boost, but then we also need to calculate we could also calculate, let me think, yeah, let's see. Okay, that's fine. Alright, so we have our weights for our items, and I'm not going to calculate any more factors into it until the system is done. I say that I'm going to get my pen and paper, and if I think of a new system before I finish this next section, I must write it down. Alright, let's, what is that? Calculate weights. Let's add that to the end of this. Okay. Alright, so the weights have been calculated. And let's go ahead and I haven't even plugged that into generate shopping list, because generate shopping list is going to be, I might have to put this section on pause until I've spent time like writing what I want everything to be valued as, because you can make a lot of mistakes trying to make an algorithm on the fly. But assuming that our weights have been calculated, I'm gonna put that on pause, and then I'll write another system and then post about it, and then have that for everyone to follow. But that's the basic gist of what you want to do. You want to give everything a weight between 1 and 100, and then we're gonna roll the dice to perform like if they would want to buy it. And the reason it doesn't make it a biased system now is because the player is rolling a dice, so each player dice rolls differently, and so that player could completely reject the first 10 items, and then maybe that player only likes the bottom 10 items. Like, it could be, if a lot of variables go into it, chances are it has a better chance of being seemingly fair to the player. More random, I would say. Seemingly fair. Okay, so that list, let's assume that list is generated correctly. Once I figured that out, and then let us seek, what are we working on? Seek out the item. Alright, so in order to seek out the item, we need to know what item it is on the list that we've decided to pick up. We need to know if there's any shelf in the store currently carrying that item. And we need to know what type of container that item is stored in. So we need to take that item, and then we need to get data table. Get data table row, I believe. And then it's going to be, okay. So for each item, that we've decided to pick. We need to find it in the row. Will that convert? That doesn't convert directly, unless I remember. There's one more thing that has to happen before I can convert it to. I need to pull it from the last time we had this error. Was when we were trying to access. Was it in the show? That's not what I was looking for. Get data table. This. We need to do enum to string and then that. Otherwise it won't print. Otherwise it will try to print like the name of the field of the enum instead of the actual enum value. Yep, so we need to do it like this and then like that. Okay, so for each of the items we want to see where it's stored. Well, now this is going to be a problem. I see a problem coming already. Because this is data, it's not necessarily an object. I'd have to use gameplay tags. Right? To search items out and about. Contains there's a problem. Let me identify the problem first. The problem is I'm going to go in here and I'm going to find the type of storage container that is allowed. But the type of storage container is in an enum and it's just a string, right? The value of the enum is just a string. There is no way. There's a way. I was gonna say there's no way to find out what blueprint contains that string. Like, I can't take the string name and then say search for all blueprints, whatever, but I can write a lengthy switch on enum statement that would do that. So okay, row storage type. I can definitely switch on storage type. This is gonna, there has to be a better way to do this. This is literally the first way I thought of. Now you can get all actors with tag. Which would technically be the same thing because the tag would just be shelf. And the next tag would be refrigerator and the next tag would be freezer. Where's the shelf? I can't say this is the best way to do this. I mean, I can't say it matters in the end. Nobody's gonna see the code, but I cannot say that it won't become laggy. Ideally, you won't have that many types of storage, but you'll have multiples of it. But essentially, you can duplicate this down for refrigerator and freezer, but basically we're going to get all actors of class, and then we're going to use a for each loop to go through each and every one of them, but this time it's going to be a for each loop with the break, because if we find the shelf we're looking for, then we're going to break. And basically we just need to know if any shelf is storing, where's my shelf? We have to get the name of it. Current stored item. Huh? Okay, get current item stored? No, I thought it was called current stored item. No, it's current item stored. I read it backwards. Okay, so we need to know enum equal. It's all the way back here. This enum. Because technically this is the initial enum we're looking for. And over here is just to get us the storage type. So we're all this to check to see if whether that is the same item that we're looking for. And we can go ahead and put our branch here. And false do nothing. True means we can stop because we found the one that we're looking for. And since we found it, I don't like that being crooked like that. I hate coming sideways on these things. They look so weird. Once we found the ones that we're looking for, we can break with that information. And now we need to get active transform. And that's where we do the AI move to. Destination, no. Then I need to get, they only want location, right? No. Not active location. I said I was gonna do nodes so that they can face the right direction and all that stuff. So before we do that, we need to put a few nodes on, because we're gonna move to the components location, but we need to put a few nodes on the shelf. And I'm doing this with this shelf, but this won't be this won't be the shelf that I use in the end, but the same thing would work. So I would just go ahead and add a couple components that are empties, so to speak. Just a couple empty boxes. Let's do another one. I want to have 2 of them, and I'm gonna rename. We're gonna call this node 1. And then the other one's just going to be called node 2. Actually, I think I need to do a couple more things before the break. But, this can basically be tiny. I don't know which side is the front of the shelf, so let's assume that they're going there, and I want a person to stand here, and then node 2 would be the same. Bring it back, let the other person stand here so 2 people can shop on one shelf at the same time. And hopefully that they won't like run into each other. And then we're gonna have node 1. Name is already in use. Node 1 use, false. Make another one. Node 2 use, and this is what I'm going to use to determine whether or not someone's already standing on the node, so they don't clash with each other. Now, in the second they find their object, they are going to essentially assign themselves to the node so that nobody gets to their object before they do. And that's kind of the best way to do it if you don't want them clashing. Now, if you recall the demonstration that I did, you would see people like weirdly waiting their place at the cash register, waiting for someone else to walk over to it, and that is because of this. Like, the placement is already assigned before they make their way over to it, and that's okay. So we have 2 nodes sitting here on the shelf. I'm going to compile. They are false by default because no one's using them, but when I go back to the NPC, there's a couple... What? Wrong one. There's a couple things that we need to do first. And that is, before we break, we need to decide, yeah, we found the shelf, right? Because that's independent from that, but we need to determine if either of the nodes are taken. So just a couple more branches. Just 2 branches really, because there's 2 nodes. Oh, because I didn't type branch correctly. So branch 1, branch 2, and let me see. Yeah, that's a just sweet and quick and dirty way to do it. I would refer to the usage of the nodes, not the actual. The physical nodes will be for location, but the uses of the nodes will be there. So if we have found the right item on the shelf, we determine if node 1 is full, and then we're gonna go and determine the same for node 2. Alright, so if node 2 is used here, we're gonna go ahead and put that in the branch there, and I'm gonna have it like that. So if node 1 is not used, golly, If node 1 is not used, we're actually going to set, not a sequence. Set it to used. So if it's not used, that means it's available. What is target self? Huh? No, that's not what I want. Alright, we're going to set node okay, so set node 1 use to what? Maybe I swear that the set node looks different all the time. Alright, so if node 1 is not in use, set it to being used and then break. We're gonna reroute this down to the bottom because we're gonna have to hit it for the next one anyway. Okay. Oh. Wait, I think I messed something up. Yeah, break the loop, but what? Am I missing something here? After I break the loop, how do I go on? Because I would call another function and then break the loop. Okay. Alright, so I guess let's make a new function. I can't do that because that's gonna push. Oh yeah, breaking the loop here is just gonna push us back here. I feel like I'm missing something. If I break this for loop, it's just gonna have us seek the next item. But I also don't want to drag off of completed, because after the loop completes, you see, there has to be, I'm must not supposed to be using this way. Because I'm still stuck in this initial for each loop for seeking the items. Buying item number 1. The only way I could break it or fix this would be to set a mode for seeking and not seeking? The music stopped. I feel like I broke something. Because the second this loop breaks, it's gonna try to run the next thing. Let's turn this into a single. Well, yeah, I know. Alright, so, wrong one. Nah, because it's that doesn't help. Interesting. Alright, for each loop with break. Once I found it, it breaks it, but she doesn't have time to go to it because it's gonna kick back. Unless the going to it happens before the breaking happens. Yeah, let's do that. I think it's meant to all come here. Alright, so node is in use. And then we're gonna do AI move to. We're gonna do all of this before breaking that loop. The problem is not get actor location, but node. I typed nose. Get node 1. Get location. I don't know if that works. Relative location? Can I not just, even if it, no, because that's gonna generate. Alright, I think I need world location? I'll see which one it is when we test it and it doesn't work. Pawn is self. Radius, target, actor. What? I don't think actor object reference, but I'm going to a destination that's a. Alright. Then I need to break from here. Okay, so that's that break, and then we'll do another one for if we set the second node in use. So it's just a duplicate of this, node 2. set get world location. Huh. Those weren't. It wasn't available for that one. Did it cut the music again? I just put one song on. Stupid. Cool. Okay, and if this is true, we have to just break it because no. We have to go back and see if that object is anywhere else. That's rough. The node placement thing is rough. Because I don't want them to say that they didn't see it if they couldn't get to it. I could have them wait and then check back later. They could wait, but if you think about it, the grabbing on the shelf and, well, I guess if they're walking to the node, but all of that happens within the span of a few seconds. If they can't get to the item, how would you have them think about it? I don't know. That might be a system I have to think about a little bit further and develop. For now, let's just pretend they can get to the item, and then we'll have to come back and edit that later. Oh, this should be on success as well. I feel like this is going to generate some errors, but so if the current item stored here isn't the right item, it's false, and then it'll run the loop again. But if it's true, we see if the nodes are available. But then that just means it's going to go to the next item. So that's what I fear. It's going to, if the nodes are full and they cannot grab it, see if another shelf has it. Otherwise, we're going to have to check back again to shop for that specific item. Okay. I guess in this particular case, I don't know if a behavior tree would be better, because it'd have to determine if there's space for the item, but the AI would still have to wait its turn or check to see if that item is there. But let's try this part first, and then we'll do the rejection part of the item. Alright, so we compile with no errors. Seek item. Does seek item happen immediately? Set value. No, that's something different. That is generate shopping list. Okay. Calculate weight. So let's take generate shopping list off here. And then get my player. Because essentially, I'm running out of numbers to use. We're gonna use number 7 for this one. That's gonna be the NPC. No, get actor of class, since there's only gonna be one for now. Until we create the spawning system, that is. And that's going to be the NPC. And I'm going to generate shopping list that way. Because essentially, you don't want it generating until I have the items stocked on the shelves to begin with. And then I'm going to have to go into the data table and for this thing and say it's dish soap that we have, right? I'm going to have to lock the rice up. So the only thing that the character can buy is dish soap. And I should actually have it print out how much dish soap it wants to buy after we generate. Okay, so since we're not using this anymore. So for false, we still set the shopping mode, but we're not using this method. We're gonna go ahead and use the method down here for seek items that we just created. You can just plop this off to the side. In the event that we need that code, at least we know, like, this is how you do it. And the name of that is going to be seek items. Target is self. And double check when it generates the list. It's gonna get a minimum of 3. We haven't determined yet, like, how many are on the shelves. If there's not enough on the shelf, then yeah, we'll determine that after we make it over to the shelves. But I need to see if this code's gonna run. So at the end of that, before we seek the items and change the shopping mode, I need a print statement, and we're going to do append. Add 2 pens. Okay. So essentially, we want to get X number of it's gonna be whatever items in the list. Technically, I only have dish soap, so we're adding to shopping list. Get. How do I pull this? keys. Get a copy. First one. That goes down here. Nope, I forgot to do the... Oh, this did the enum to string because I'm plugging it into a string and not the other, not into a name. Alright, so enum to string here. And then I got keys, I need values. Okay. All right, let's move all of this stuff over. Alright, so now, well, after, alright, so this should tell me at the end of generating the list what it does, and let's take seek items off of there. No. Do I have generate or, alright. Because I have the player character generating the list first, so seek items happens automatically. Let's give it a shot. Nope, I lied. What? Box? What the box have to do with anything? Did I take a value away from box by accident? This stupid bug again. I changed some information in the data table, so it thinks this doesn't exist anymore. Even though it's literally right there. Refresh. This is gonna happen to this script every time. But there's nothing I can do but just keep plugging in X and Y here. Every time you add something to it, it's gonna rewrite that data, unplug everything. And there we go. Don't know why it can't keep the same value, but alright, so there he is up there. He shouldn't be seeking or doing anything because I need to grab number 3 and stock the shelf really quick. Otherwise, he won't know that there is a shelf with this stuff on it. Should not have picked up that box. Let's try it again. I didn't connect it to the put down system yet. We only have the pickup system. Alright, so now that I've stocked the shelf with the dish soap, he should be able to find it, but I'm pretty sure I'm gonna get error, so I want to get 5 number of candle. No, candle doesn't exist. Why was he allowed to search for candle? Drinks has dish soap. Candle isn't even in the list. This is the unlocked list, right? Dry goods, drinks, snacks. The unlocked list for rice is false. The unlocked list for the candle's not even on here. He shouldn't have been able to ask for that. Why was he able to ask for candle? Why does it works though, by the way. Generate the list. Let's go. It's not the weighted list that I'm gonna create with a little bit more math, but it is a general list of stuff he wants to get. He should not have been able to ask for candles. Let me go over here, save all. Maybe something was wrong. And then if it still tries to ask for candles, then I will go in. Yeah, he wants 4 candles. Why? Let me look at the game manager, because the game manager has the hot items and the items that we've unlocked. Oh, I put default values. That I shouldn't have done that. Items unlocked. Clear items unlocked. Get data table row. Items unlocked. There we go. So it should generate the items unlocked now. Let's just put like, I don't know how many he's gonna want. He can only have 5, but alright. No, it key infinite loop NPC. It doesn't like that. Wait, there's no infinite loop. I mean, if they say there's an infinite loop, there is. Where? It took me to this. No, I'm pretty sure everything goes off to break. Everything goes to break. Is break not what I think it is in Unreal Engine? Does break mean something else? Because I thought that meant stop the loop. This isn't infinite. Get all actors of shelf. I wish it told me where an infinite loop would be. Or what does break not mean what I think it means? I thought break meant stop. Like a return or something, just like stop. Like break the loop. There's no way this is infinite because it can only cycle through the number of actors in the array. Same for this one. This can only cycle through the number of actors here. Again, all items unlocked. I don't see it infinite unless break doesn't mean what I think break means. Because I didn't plug anything back into execute. Yeah, I'm lost. I have to be using that wrong then. Alright. Wait, you know what? It didn't generate this error until I took the candles out. It didn't give me an infinite loop thing until I took the candles out. Which means it processed that and just didn't find it. I'm not going to run it again. But I am going to have to check whether or not shopping list is empty. It shouldn't be empty. No. Oh, yeah. That's the infinite loop. My other empty. The other one where I check to see if it's empty or not. This is the infinite loop. This right here. If it's empty, generate shopping list. It's always empty. This is what kicked back, not the other one. Because it only kicks back after I took out those default values. So it tells me that this isn't pulling the items that I have unlocked. Why does it keep cutting the music? I don't have to stare at the freaking screen to play a dang song. Like, seriously. Okay. I'm gonna assume it's this. Hmm. Can we print what's being added? I don't think anything's being added. Now that I took the candle thing out. NPCs, delay call. Infinite loop detected. NPCs function, delay call. How is that infinite loop? Then begin play, delay. Did I not wait 3 seconds before pressing the button? No. Because more than 3 seconds. I swear it's that, but I'm gonna do this. I don't think that's the problem, but I'm pretty sure the problem didn't come up until... Yeah, it's not that. The problem is generate shopping list, and it's saying this is an infinite loop. Because if the list is always empty, random bool condition. So you mean to tell me this random bool is never going to generate a false? It's random. Sometimes it will, sometimes it won't. Oh. Maybe because I have it going back up there after completed? But that wasn't the problem when candle was in the list. No, because completed only checks if it's empty. If it's not empty, it goes on. So all items unlocked just isn't pulling anything. That's the problem. All items unlocked is infinitely empty. But I don't know why. Game manager, all items unlocked. Oh, update item list. Never happens. And it was taking the default values. Event. This is a game manager, so there's no event begin play. This should be under init. No, this isn't. Oh, this is a different script. This isn't the game and thingy, Bob. Yeah, that should be connected to that. Therefore, it will always generate information. It won't infinitely be. Okay, so I can plug in this again because this was not the problem. I didn't think it was, but there we go. Save everything. Let's go ahead and give that another test. 0. Wait, what? What was the 0 for? 0 what? Who's printing 0 before I get to do anything? Game manager? Yes, you're printing 0. Why? Oh. Alright, I'll take the length. One. That's all we needed. Alright, start the shelf. 7. I want 3, number of dish soap. I think he might be going to get it. What? If he goes to the shelf, well, because the nodes are empty, so he should be traveling to... No, he's not going. Why is he doing the old behavior tree? No, he isn't. He's going to like 0, 0, 0. Okay. That's because I used, what did I use? Because I couldn't get the world location from that one for some reason. And it got relative location. But he would go to node 1 because in the likelihood of them clashing, I mean it's bound to happen, but they grab stuff off the shelf and the same person isn't always looking for the same item, and you're not gonna have all customers in your store all at once. So the likelihood of it happening is slim, but it could still happen. Okay, let's go ahead and stock the shelves and tell him to get 5 dish soaps. Alright, let's see if he comes to get it. That location thing is going to be the problem at this point. No, he can't remove it off the shelf yet, but he can go to the shelf. Is he going to? He went directly to his node on his shelf. Yes! Now all we gotta do is get him to remove the dish soap. Alright, he's gonna take it from off the shelf next. Awesome! Now, hopefully, what's supposed to happen, now I know this scenario could still happen. He's gonna grab whatever, he's gonna grab his 5 soaps off the thing or whatever. And we do have to do a lot of calculations next on whether or not the dish soaps is there, the number that he wants is still there, and if not, we'd have to subtract that from the number that he is able to find. So, by the time he gets here is when he does the calculation. So depending on how many dish soaps he wants after we put the math in, I'm gonna pack them back up in the box so he doesn't have all the number that he needs, and we can do that test and then see what happens. Alright, but he made it right over there, so if this had animations, it would look so much more normal. Right now he's just standing there with his hand on his hip and his mouth wide open. I don't know. But we're making progress. Okay, so no errors. All of that worked. All of this worked first try. The problem though is, how would I say? No, I guess that really isn't a problem. If you take into account the size of a shelf, and sometimes people were stacking things like up and down, but it wouldn't really matter if they stack it up or down or left or right, because this will have its own nodes and they can get from any shelf, and then that will have its own nodes as well. You know what I just thought? I searched for individual shelves that had, let me show the search. There's a problem here. When I found the shelving unit, I searched for the shelf and then the array element. But each shelf platform can have their own item. So the current item stored is relative to not the whole shelf, but one row on the shelf. So at some point we have to kind of make this a multi-level shelving unit. So we're gonna have to change the way that we reference all of the pieces, because right now we're referencing the shelf as a whole item, where we're gonna need to be referencing the tiers on the shelf. A problem for another day. Let's go ahead and get him to collect his item. So once he's made it over there on success, we're gonna need him to take I'm gonna make some variables. This is because I need information from like way back here. So the shopping list key pair. The element is the item that they need. So that's going to be currently seeking. Well, okay, so that's currently seeking. What about amount? Where do I get amount from? Because this is just a key. The value. I need value. Blah, blah, blah. Alright, so the value is going to be not gate. Get a copy. It's going to be the same array index as this. And I'm going to have to promote that to amount seeking. Just so I can use them in a minute. That's not neat at all. Let's move. Okay. Alright, so that's the information, because I'm going to need to use that over here, and it just doesn't make sense. Oh, wait. That was... okay, yeah. Yeah, it doesn't make sense to do all of that. So, now that I have... once we get there, and I'm going to do it up here and then duplicate it down there. But it's basically going to be the same thing. Once he makes it to the location, oh, I need a copy of the shelf information too. Amount stored, I think. I could just promote this to a variable as well, but let's just use this like that. For now. Alright, so the amount stored needs to be, how do you say, let's say, I want to double check if the amount stored, nope, not greater or equal to the amount that we're seeking. And if it's true, then hooray. But if it's not true, then I need to know how many is left and how many he's not able to get. So amount seeking. Alright, so if it's true, let's just plug that back up so we can know that goes down there. Wait, I guess the false is gonna go back down there as well. Amount we're seeking. Take and subtract. Okay, so ideally you want to know how many is left over. So the remainder is going to be what you cannot get. So amount you're looking for, because we've already established that it's not greater than or equal to it. So if it's not, I need to know how many are left over, or yeah. So if it's, so this is just saying that the current amount there is less than what I've got. So how many less is what I'm trying to figure out. So the amount I'm seeking is, alright, let's subtract it, and that's gonna give me the remainder of basically the remainder that he's still looking for. Now that I think about it, it's going to give me the remainder he's still looking for on this shelf only. So we're going to have to run the loop back around to see if we can even find this on another shelf. Or if there's none left in the store at all. But amount seeking can be set to this new number. And then we're gonna have to look to see if it's still any more in the store. And then if it ends up not being any, if we run, that means we ran through the whole list and it's not in the store. We'd have to loop back around. Yeah, because how would we say we're still searching? The way to say we're still searching for the item would be to put to not change the array index to the next one if we are, there has to be a cleaner way to do this. I'm gonna have to think of a better way to do this because this is getting messy with all the things that we need to check for. Because it's not, if it's not on this shelf, it could be on another shelf. But so long as we are still above 0, we still need to be searching for this same one item. If I break out of this loop, it's going to try to search for the next item. Unless I go back to something that I had said earlier with the shopping found. I had said earlier to break. No, because then you'd be going to different shelves every time you wanted one item instead of standing there and getting multiple. I said break it up into a larger list and have each item be an individual item. Um, so, like, if you wanted three of something, it'll be in that list 3 times. That way, you could just run the seeking for it individually. But then there's that whole, is it sitting right in front of you? Yeah, so this is interesting. I'm gonna have to devise a way to write these algorithms, but it's not gonna be something that I can do on the fly, and it's getting pretty late. So I'm gonna take some time to write those and say thank you so much for joining. It's been a pleasure. We got some of the AI going. We stored some important information, and we got the AI to walk around, or at least walk to the nodes on the shelf. So there has been some progress there, and we'll continue next time with AI. But until then, take care and see you then.